Let's take a look how you can use cluster info to demonstrate basic service functionality within Kubernetes. So we're on the services page, and let's go ahead and create a basic service and a deployment for that service. So we have here a basic cluster IP service that is a load balancing traffic across various replicas of deployment. Now that service is a cluster IP, so that means it is only accessible within the cluster and not accessible anywhere outside of the cluster by anybody external. So let's go ahead and convert that service to a node port. Now we have a node port associated with that service that we can access that service from outside the cluster if we had access to any of the IP addresses of the nodes within that cluster. But in a cloud scenario, we generally don't have access to that, so a node port really isn't of use in a cloud scenario. So let's go ahead and take this to the next level and upgrade this service to a load balancer. Now when we do that, we're asking Azure to give us a public IP address, and that's exactly what Azure is going to do. And it's going to take about 5 minutes or so for that public IP address to propagate. And when it does, we can use that public IP address along with the port that the service exposes in order to be able to access the workload that the service is referencing through its label selector. So let's go ahead and give it a few minutes for this IP address to propagate and then come back and take a look at the service. It's been a few minutes and now the IP address is propagated. We are able to use this as a public IP address from outside the cluster and access the service. So let's go ahead and go to that IP address, and we have at this IP address in this sample an image that refreshes itself every 3 seconds or so. And you can see that every time it refreshes, it's the load balancer is sending that traffic to a different pod. Now in this case, it's bouncing across 2 pods that happen to be on the same node, but if it chooses, it can also balance that traffic across other pods on other nodes. Now in this particular case, we can see that it's bouncing it across here. That's purely coincidental. It can balance the load across any of these pods, across any of these nodes. So let's go ahead and take a look at that. So now let's take a look and see what happens when the deployment changes. What happens to the service when the deployment itself changes? So we'll pull up the service. We'll go ahead and pull up the image and set it to the side and watch what happens to this application as we update the service itself. So in this scenario, we're going to go ahead and update the image to a different version. By default, deployments use a rolling update strategy, so they're going to slowly delete the old pods and create the new pod. So at any given time, you could have the user access both the old and the new, and so now the new pods are being created. So at this point, the load balancer could start balancing the traffic against any of the old pods and the new pods. So if either one of these is deleted, it should start balancing that traffic across various new pods. So there we go. So now the load balancer has the old and the new pods at its disposal, and it is starting to balance the traffic. And then once the old pods completely disappear, then all of the traffic will be across new pods. Now in this particular case, the images is all the refreshers seem to be going on the same pod, but if we bring up a different browser, we can see that those are balanced to a different user to a different set of pods. So that's how you can use cluster info to demonstrate a load balancing and deployment changes in Kubernetes. So let's go ahead and clean that up. And while it's being cleaned up, let's review what we did during this demo. We deployed the original deployment along with the cluster IP service to balance traffic across that deployment. We changed the type of that service to a node port, then we changed it to a load balancer, then we updated the deployment to the new image, and then we watched how the load balancer started sending traffic across that new image, and then we cleaned up. So that's how you can use cluster info to demonstrate services within Kubernetes.